Well, here we go. Guys, welcome back to Coding Path. We're going to do another HackerRank challenge with Java and 30 days of code, trying on something different this time with the picture-in-picture. Hope this works right. So let's go. So right now we're doing with 2D arrays. This is day 11 and 30 days of code. And it says we're going to build on a knowledge of arrays. I've actually already read through this, so I can kind of summarize it and save some time. Basically, they're going to give us a 2D array that looks something like this right here. It's going to be 6 by 6. So we think in terms of indexes and arrays. This will be position 0, 0. And the last one will actually be position 5, 5. This is 1, 2, 3, 4, 5. This is 0, 1, 2, 3, 4, 5. So that's 0, 0. This is 5, 5. That's our array. And we're going to take something called an hourglass, which is a sum that looks like this right here. So it's the first 3 going across the row, that little middle guy, and the next 3. So if we were to take this top section right here, if we were to start with position 0, 0, it would be this one, and that one, right? And then the one that's right here in the middle, which is the second row, and then the third is right here, 1, 2, 3. That would be our hourglass. What they want us to do is add those up. So in this case, it would be 1, 1, 1, 1, 1, 1, 1, 7 1, so the sum would be 7. Really easy. So what we're supposed to do is iterate through this array and take all of the little hourglass sums and then just print out the console which one is the highest. So you can probably already think in terms of there's an iteration, there's going to be some for loops, things of that nature. They tell us in advance there's 16 hourglasses in this particular array, and I think in the problem there's going to be the same size, so that's really cool. And the reason there's 16 is because you start here, 0, 0, 0, 1, 1, 1, no, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and then 2, 0, 2, 1, 2, 2. So you start there, but you'll end right here with this guy. And this guy is 1, 2, 3, 1, 2, 3. So the last one you're going to do is 3, 3. Because once you get here, if you can, I'm trying to point with my finger, which is ridiculous. But once you get here, if you count 3 over, then that's that little block right there. That's as far as you can go. So we're not gonna, when we do our loop, we're not gonna go all the way out to the end because we're gonna have a out of bounds error, right? Even if we were to go right here and add the next 2, there's an out of bounds error. So our loop, whenever we do our loops, we know we're gonna start with the top position and go all the way to this guy in order to get that hourglass, which would be 1, 2, 3, 1, 1, 2, 3, okay? So the task says calculate the hourglass sum for each hourglass in A, then print the maximum. All right, cool. They give us a lot of little introductory stuff here, no big deal. There's a sample input, which is the same as this one. It's a 6 by 6 matrix. So again, in terms of like indices in a 2D array, this would be 0, 0 up here in the top left. And this would be 5, comma 5, X and Y, bottom right. And the sample output here is 19. They even break it down even better here to show us that A contains the following hourglasses. So if you were to just look at all the different hourglasses in there, it will come out to this. I don't really need that for this problem. The hourglass for the maximum in this case would be 19, which is the one that has the 2s and 4s. I think this one right here. 1, 2, 3, 4, 5, 6, 7. Yeah, that'll be 19. This guy, that guy. And so here we go. We're in Java 8, which is the comfortable language that I'm comfortable in. They typically give us some starter code here. We call it a class solution. We've got our scanner method here going on. We have our scanner object taking in the new input. I've got our main method right here. And they go ahead and define the array for us. So it's going to be an array of integers. It's a 2D array. And it's a 6 by 6. And this is the iteration that is going to go from 0, 0, you see it right there, to 6, well, 5, 5, because it's less than 6, so it's 5, 5. Which means what we can do, we can take advantage of this iteration. They're using it to populate, but since we're populating, we can go ahead and jump in here, right here, and do our summing as well. So let's just define some variables real quick in a nice global scope type of way. So we're going to have a sum of all these hourglasses. So let's just say int h sum. We can initialize that at 0. And what we're trying to get to is the biggest one of these. So whatever, int h sum big equals 0. And again, I'm putting it outside the loop so that if I'm going to console log something out, at the end, it'll have access to those variables. So we have two variables, hsum and hsumbig, and they do the iteration for us, which is cool. So we're going to just get in here and do some good old-fashioned arithmetic. So what are we doing? Let's look at it. We're going to add, let's just take the first one we're going to do. We're going to do this one, that one, these three, and these three. Except for hourglass, if you look at it, you take out those two spots. So it's really these three, that one, and these three. Does that make sense? So this is position 0, 0. So here we have 0, 1, 0, 2, right? Then 1, 1, then 2, 0, 2, 1, 2, 2. Okay? So if you think in terms of variables, a way to generalize that, what would that pattern be? So if this is x and y, right? This is x, y plus 1. This would be x, y plus 2. This one here would be x plus 1, what? Y plus 1. If that makes sense. Where x are the rows in this case. And then this one here, this number 1 right here, this 1 would be x plus 2. Well, x plus 2, 0. Start over. X plus 2, y. X plus 2, y plus 1. X plus 2, y plus 2. And you want to generalize it like that because that tells you whatever that pattern is, you're going to follow that same pattern all through here, regardless of what the starting number is. So we just happen to start with 0, 0 here, and we follow that. But when we get down here to 1, 2, 3, 1, 2, we get down to 3, 3, we can follow the same pattern. It would be 3, 3, and then what? 3, 4, 3, 5. And then 4, 3, 4, 4, 4, 5, then 5, 3, 5, 4, 5, 5. So the pattern is still xy, xy plus 1, xy plus 2. Hope that makes sense. So down here, and there's more than likely a way to simplify this, but I'm just going to hard code it right now. I'm just going to brute force it, if you will. So our sum, each time we iterate, our sum, h sum, is equal to what? The array item. So we'll start with ij, and I'm thinking in terms of 0, 0 at this point, right? So that's the first one. And then 1 over would be what? I, j plus 1. That's the very next item over. And then add to that, array I, j plus 2. So that's the first row. The second row, we don't need that first one and that last one. We just need the middle guy. So what was that? That was array I plus 1, j plus 1. We're done with the second row. And the third row is going to be array I, j plus 2. J, no, that's wrong. That's wrong. It would be I plus 2, j. So the second row, the third row, which is I plus 2, and the first column. Then array that one, j plus 1. And then array I plus 2, j plus 2. Let's just see if that makes sense. If this is 0, 0, this will be 0, 1, 0, 2. That's that first row. And this will be 1, 1. That's the second row. And this will be 2, 0, 2, 1, 2, 2, which is the third row. If it started with 0, 0, but now if it started with 3, 3, what would it be? It would be 3, 3, 3, 4, 3, 5, 4, 4, which is what? Which one would that be? 4, 4 would be this guy right here. 4, 4. Well, 4, 4, right. And what else? 4, 4, and then 5, 5. Okay. So that's the sum. Each time we iterate through, we can go ahead and take the sum. I don't have to do another iteration, I don't think. So having done that, so that's our basic accumulator pattern, but we need to compare that to the next one that we do. So we already said h sum big is 0. That's going to be our biggest. So let's just say if the current sum is greater than the biggest we have so far, which is h sum big, then if it's greater than the biggest needs to be that. So if the current sum is greater than the biggest that we have, then the biggest that we have should be the current sum. Look at that for just a second. It's really easy, to be honest. It's just an accumulator pattern and then a quick check. And then after that, get out the loop. Where's my loop? Get out the loop. And we're going to simply print the biggest one. System out. Print line h sum big. Run the code. Out of bounds. Out of bounds. Didn't like that. No response. Out of bounds. Why is it out of bounds? Oh, you know what? We do need to do another iteration because the first iteration populates all the fields. I can't go to 6. I can't go from 0 to 6 as I'm doing this. Because if I go from 0 to 6, it's going to try to, and I just said that, that's so crazy. It's going to try to add all the way through. I need to go from 0 to 3. But since we use that pattern of the less than, it'll be 0 to 4. Alright, so, crap. Where's my arrays? Where's my stuff? So let's just get rid of that. And then we're going to, where are we? Let's just get that up there. So let's get out of this for loop and get out of that for loop and do it again. So for int I equals 0, I less than 4, which will stop on 3, I plus plus, and then go into your j. So that's all the rows. And now let's do the columns. So for int j equals 0, j less than 4, j plus plus, and now we're going to do the sum. That'll go right here. We need to indent sum. That goes right there. All right. And then do our comparison. So if h sum is greater than h sum big, then h sum big equals h sum. Let's try that. So we passed the sample test case. Green is good. Congratulations. Let's go ahead and submit the code. Before I submit that, let's look at it one more time. Hopefully this one was super easy for you. I had to struggle a little bit, but I think we're okay now. They gave us the basic iteration to populate the array. So then we just had to come out of that, iterate back through it from position 0 to position 3. That's why we put less than 4 to position 3. And in that iteration, each time we come to that column iteration, we added a sum. Now, when I first looked at this problem, I was thinking in terms of taking all those sums and then doing some kind of a sort. That didn't even make sense. We just compared this one to this one. And then whichever one's bigger, we say that as max, and we compare that one to the next one. And you keep on going through. So you only have to save 2. You don't have to save all 16 of them. So let's run the code. Ooh, 2 cases failed. Why would that be? Let me turn off that music so I can concentrate. For I int equals 0, I less than 4, 0 less than 4. See, 0, 0, 0, 1, 0, 2, 1, 1, 2, 0, 2, 1, 2, 2. That looks good. That looks good. That looks good. Why would it fail those cases? Well, we're going to stop the video and figure out what that is. Thank you all for watching, and we'll see you next time. All right, so we found the problem, rather. And the problem was our initial sum amount.
I had it at 0. You've seen I've changed it to negative 63. The question is why? Well, when I failed, one of the test cases that I failed included some negative numbers, which I wasn't expecting that. And so if there's negative numbers, that means it's possible that the total sum is actually less than the max that I assigned. So I had to go back to the problem, read the problem, just like my math teacher taught me, and I see that our numbers can go from anywhere from positive 9 to a negative 9, which means if we have 1, 2, 3, 4, 5, 6, 7, 7 positions of a negative 9, 9 times 7 would be 63. So I changed that 0 that I had there to a negative 63, submit the code, and it worked. And that is the 2D array problem in the 30 Days of Challenge in HackerRank. Hope you all learned a little something. Talk to you soon.